let's say we've been given first complex number z1, which is in polar form as r1 cos theta 1 plus this is I sin theta 1, and then we've been given another complex number z2, which has got r2 cos theta 2 plus I sin theta 2. Now we want to add these two complex numbers. So addition and subtraction of complex numbers is really the same. So all we are going to do is we are going to expand these two complex numbers and make sure that what is the same, we add them alone or subtract them alone. Those which have got cos alone, those which have got sine alone. So we can distribute this r to everything inside, and so we're going to get r1 cos theta 1 plus, now we are going to have r1 sine theta 1. I can put the I at the end, and then the other one here we're going to have r2 cos theta 2 plus r2 sine theta 2. I can also put the I at the end. And so if you add z1 plus z2, all you do is the portions which are the same, those containing cos, add them. In other words, the real parts, add them together. The imaginary parts, those containing an I, also add them together. That is really how we add complex numbers. And so that is going to be r1 cos theta 1 plus r2 cos theta 2. So this is the real part. And then plus, now we go to the imaginary part, that is r1 sine theta 1 plus r2 sine theta 2. So because I is common, we are going to put the I outside because both of them are imaginary parts. So that means if we add the minus here, this is also going to be okay. If that was a minus, that means this is going to be a minus. We're going to subtract the second from the first. Even this is going to be a minus. So basically that is how we work with complex numbers addition in polar form. Now mostly we want to make sure that we first convert them to the rectangular form, and then after that we can now convert them to polar form. So let's say we've been given 4 root 2, and then we have got cos 60 degrees plus I sin 60 degrees. This is the first complex number z1 which we have, and then let's say we've been given z2, which is equal to, we can say 3, and then we have got cos, let's say 30 degrees, and then plus I sine 30 degrees. So if these are two complex numbers that we've been given and we want to add them, so how do we get to add them? Well, it will be very simple first to write these two complex numbers in rectangular form. So the rectangular form is a form in which complex number exists in the form a plus ib. And so what we are going to have is 4 root 2 here. Now cos 60, if we consider on the spatial angles, this is a 60, this is a 30, 90, this is 1, this is 2, this is root 3. So cos, we know cos is adjacent over opposite, so cos 60 is 1 over 2, and then plus I sin 60. Sin 60, if we consider here, sin is opposite over hypotenuse, it's root 3 over 2. And then we have got z2 there. We have got 3 cos 30. So cos is there adjacent over hypotenuse, so it's root 3 over 2. And then plus I. Sin 30 is 1 over 2. So we've expressed now these two complex numbers. What we are doing is expressing them in rectangular form. All you do is to find the value of cos of the angles that you have. And so 4 root 2 times 1 over 2, that is going to give 2 root 2. And then plus this again multiplied by that. So we can see that the 2 can go into 4 there. And that is how many times? That is 2 times. And then this root 2 and root 3 is going to give us root 6 if we multiply them. And then the other side we have got, if we multiply this by that will be 3 root 3 over 2 plus 3 times 1 over 3 is going to give us, 3 times 1 over 2 is going to give us 3 over 2. Remember, we have got an I there. Even in this side there is an I. So these are the two complex numbers now in rectangular form. Now we can add them. So this will be z1 plus z2 is equal to, we'll get the real parts and add them together. So that is going to be 2 root 2 plus 3 root 3 over 2 as the real part. And then we have got plus, we get this portion, we also add to the other, that is negative 2 root 6, and then plus 3 over 2i. Well, simplifying what we have here, this is going to give us 4 root 2. All we do is multiplying this and that, and then we get the sign which is here, that is a plus. Now the denominator here is a 1. Multiply this by a 1 which is down there, that is going to give 3 root 3, and then multiply the two denominators together, that is going to give us a 2. And then the other side also, this times this, that will give us a negative 4 root 6. There's a denominator of 1 here. 1 times the 3, it is a positive 3. Let me write it in front there. And then 1 times 2, that will be a 2. So that will be now the addition of those two complex numbers. Well, if we wanted to leave this in polar form, we need to find the exact value of this and the exact value of this, so that we will be able to take it back to polar form. So if we punch on the calculator, that is 4 root 2 plus 3 root 3, and then divided by 2. So this is giving about 4.27, plus the other portion 3 minus 4 root 6 divided by 2. That is giving me a negative number, so this is going to be negative 3.399i. So this is the sum of these two complex numbers. Now we want to leave it in polar form. So from here then, what do we do to take it to polar form? So we need to write it in the form r cos theta plus I sin theta, and that we just find the value for r. Finding the value for r, we're going to get the x. This is this portion, 5.427. We are going to square it, and then we are going to get this value here, which is negative 3.399. We also square it and then square root. So 5.427 squared plus the other one. Okay. 427 squared square root. So r is giving me 6.40. This is the value for r. And the other value that we need to find is the angle theta. So theta is given by tan inverse y over x. So the y value here is the value containing I, the imaginary root. So that is negative 3.399 divided by 5.427. So that is going to give us negative 3.399 divided by 5.427, and then taking the tan inverse of that angle, that is giving a negative 32.06 degrees. Now we need to understand in which quadrant this complex number is the result. So I can see that x is positive, y is negative, so it is in this quadrant. Actually it's here. So we want to give the value of x which is positive, and mostly we take from the positive x-axis up to that point. Now if we want to give the angle just between 0 and 80 degrees, then we can take it from this point. It will still be a positive value instead of all the way. So we have removed 180 degrees, which is this portion. We've just gotten it from that point. If we want to give the value just between 0 and 180 degrees, so to this angle, to convert it to positive, we're going to add 180 degrees. So that is going to give us 147.94 degrees as the angle theta. Then we can say 5.4. Okay, let me just name it as Z1 plus Z2. After adding them, we are going to convert them in the form R. Now R gave us 6.4, and then open brackets, cos theta. The angle theta we found is 140. We can just say that is 148. And then plus I sine. The angle theta is still 148 degrees. So this is the complex number, the sum of those two angle complex numbers if we add them, which is the same as this one in rectangular form.